So here's an open-ended calculus question, and I love this question so much, so I just have to do this. And we're going to use what we know about derivatives to solve this. So we have this line L that's tangent to the graph of y is equal to x minus x squared over 500, and it's tangent at that point Q. And the first thing is we're going to find the x-coordinate of point Q. Well, using what we know about derivatives, if we know that this line right here is tangent to the parabola, then we know we can find out the slope. We can use y is equal to x minus x squared over 500. We're going to be able to find y prime, and from the slope we are going to, that's supposed to be a little L there, we're going to find the equation of the line y is equal to some function. Using this information, we're going to use this. We're going to find that y is equal to some function of, this is just going to be just a function of x's. And then, if it's tangent to the parabola, we're going to use the fact that the y value must be shared by the parabola and the line. So we're going to use that y is equal to x minus x squared over 500. So if they share this point, so this is, I'm going to write P for parabola. If we know that they share this point, then it must be true that this expression that we get here must be equal to this expression right here, and we're going to solve that for x. The next prompt here says to write an equation for the line L. Well, this is great, right? Because we're going to have y prime, and from that we are going to be able to substitute in our x, right, the x that we found, because y prime is going to be a function of x. We're going to be able to find the slope of that tangent line, and we also have a point on that line. We have the point 0, 20, and from that we're just going to use point slope form of our equation, point slope form for the equation of a line. And now this last piece right here, suppose the graph is shown in the figure where x and y are measured in feet. Okay, we put a 50-foot tree up at the top of this hill, and the next so to answer this question, does the spotlight at point P directed along this line shine on any part of the tree? And from that, we can use something we know about parabolas. We know that the vertex of a parabola must occur between the two roots. I mean, the axis of symmetry must occur between these two roots, and so the vertex is going to be right in the middle. So we'll be able to use the point 250. We could also find the maximum of this function just by taking the derivative, and you'd confirm that in fact the maximum occurs at x equals 250 if we do that. And we're going to take that value of y and we're going to add 50. So we're going to find our y value. We're going to find our y value for the vertex. We're going to add 50, and we're going to compare that value to the, let me do that in a different color. We're going to have our equation of our line, which is going to be here. Use our equation of the line, and we're going to evaluate that at x equals 250 and see if it does in fact reach that height right there. So that's our roadmap. I'm going to use my calculator on the next part and find those values.